All right, hello everyone. This video is going to serve as our kind of support to introducing the breadboard. So that tutorial that you guys started, this video is just going to support that a little bit. So as you know, we've talked about breadboards. And your breadboard is basically a prototyping tool that electrical engineers will use to test out circuits before they build a final product. So that tutorial and what this video is going to walk through is basically creating and testing a circuit using a specific type of LED called an RGB LED, which we're going to talk about a little bit later. So when we look at our breadboard here, we're going to see that our breadboard is full of a lot of pins or a lot of holes. And each one of those holes allow us to make connections, electrical connections to different parts of our circuit. So if we look at either the left side or the right side of our breadboard, we're going to notice long rails that run the entire length of our breadboard. We'll also see that they're labeled as either positive or negative. That's going to be on both sides of our breadboard. And if we hover over any hole or any kind of connection point on the positive side, we're going to see that all of those holes light up green. And that means that all of them are electrically connected together. And the same thing applies to the negative side of our circuit, or of our kind of rail here. So all of these are going to be connected together electrically. So let's start putting together the pieces of our circuit here. So we obviously have our breadboard placed in here. Let's put in our 9-volt battery. So when we drop in our battery, we can rotate our battery or any component that we put into our circuit, we can rotate, and we can just select that individual item, and up in the top left corner of our screen we can click rotate, and when we do that, our object will start to spin around. So if we look closely at our 9-volt battery, we'll see that we have a red end and a black end. And those are going to line up with our red and black rails of our breadboard. We'll also see that one is labeled positive and one is labeled negative. So if we would just kind of pan over the end here, we'll see that we have a positive and a negative. So let's drag and drop our 9-volt battery into our power bus here on the left-hand side. So if we zoom in on this, our positive terminal is plugged into the positive side, and our negative terminal is plugged into our negative side. So when we zoom out, we'll see that we have our battery plugged into our breadboard. So if we hover over any of our connection points here in the middle of our breadboard, so let's just say A6. If we hover over that, we're going to see that that entire row lights up green. And that means that all of those connection points within row 6 are going to be electrically connected together. So if we would hook up a wire or make a connection in row 6, we're basically making a connection to row 6A, or letter A, row 6, letter B, row 6. So all of those are going to be connected together. So let's put in our RGB LED. So on the left side of our screen is all of our components, and we can scroll down until we find our RGB LED. And we're going to rotate this 90 degrees. So again, we can use that rotate tool up in the upper left-hand corner. And what we're going to do is we're going to place our top pin. So it's going to be labeled red if you pan over it. We're going to put our top pin in row or in section E13. So we'll come over and we can find row 13 and come all the way over to E. So if we look, we can follow E all the way down to 13. So we want to make sure that our top pin is in row 13 and letter E. Now we're also going to need a resistor. And again, all your resistor does is slow down our current flow. So it reduces our current flow. So we can come over and we can find our resistor. And for now, we'll just place it off to the side here because we're going to need to adjust our resistance value. And we can do that pretty easily. If we just select on our resistor, you'll see that our options bar kind of pops up and we can assign it our required resistance. So in this case, our required resistance is 480 ohms. So we can go from K ohms to just ohms, and we can type in 480. And when we did that, you may have noticed that our color bands on our resistor changed. And again, that just has to do with the color coding system that we previously talked about. So now we can put our resistor into our circuit. So to put our resistor in our circuit, we can just press and hold, and we're going to put that in point D14. And we're going to talk about why that specific section. So it's going to go from D14 down to D18. And again, a resistor can go in either direction. So it doesn't have to be facing a specific direction to work. So we talked about LEDs in the past and how LEDs have typically a positive lead and a negative lead, sometimes referred to as a ground. But that's going to be our cathode. So your cathode has to be connected to the ground or the negative side of our battery. Again, those terms kind of get thrown around back and forth, but it needs to be connected to the negative side of our battery or the ground. So right now it's connected to our resistor, and our resistor goes to row 18. So we can just connect a wire from row 18 to our negative rail. And to connect a wire, we can just press once in any hole that we want to start and move over and press again to make our connections there. So currently we have our RGB LED with our cathode or negative or ground plugged into row 14, our 480 ohm resistor plugged in from row 14 to 18, and our ground or negative wire running from our negative terminals to our row 18. So now we can start to put in our push button switches. We're going to need a total of 3 of these push button switches. So we can just start with 1. And when we place this, we want to rotate this 90 degrees. Once we rotate it 90 degrees, we're going to put our top pin in row 1 in column E. And then that means that our bottom terminal, or terminal 2, is going to be in row 3 in column E. The other side of our switch, we're not necessarily going to worry about for now. So these push button switches the function of them is relatively simple. Essentially, we push down our button, it's going to make a connection and complete the circuit for us. So when the button is not pushed, our circuit is technically open and our current will not flow throughout our circuit. So we're going to need 2 more of these push button switches. So our second one, we're going to put in row 5, column E, and our third one is going to go in row 8, column E. So they should all be in a nice kind of line at this point. Or I'm sorry, let's move this one down one. So it's going to be in row 9, column E. That way we have the same spacing throughout all of our switches. So I'll give you guys a second to get caught up there if you do need that. Okay, so now we have our push button switches in there, and we need to basically complete our circuit. So as we've talked about, in order for a circuit to be complete, we need to have a full path from the positive to negative side of our batteries. So we need to have a full and complete circuit or a full and complete path. So we can start to put these paths together. So if we look at our LED very quickly, we'll see that we have a red terminal, a blue terminal, and a green terminal. And that just signifies that each one of our legs or terminals is going to give us a different color to our LED. So we have our negative terminal hooked up, which is our cathode. Again, that was through our resistor. So now we need to hook up our red, blue, and green terminals through our switch and then to the positive side of our battery. And that's going to then complete individual paths to and from our battery. So to do this, let's start with our red terminal here. So we'll run our red LED, or when we want our LED to light up red, we're going to use our top switch here. So we need to connect our red terminal to one end of our switch up here. So let's connect a wire in row 13 all the way up to row 3. And we're going to change that color to red just so we can easily identify these different wires. So at this point, we've almost completed our path to the positive side of our battery. Again, we need a full complete path to and from our battery to complete our circuit. So at this point, it can flow terminal here through our wire, resistor, through our LED, through our wire, and let's hypothetically say they can flow through our switch at this point. Of course, our switch isn't pushed down, but let's say it can. So now it's in row 1. All we need to do is from here, connect row 1 to our positive terminal. And when we do that, we've now completed a full path. So if we start our simulation here, obviously these two buttons will not do anything. We don't have any wires hooked up. There is no path for our current to flow. But if we click our top switch here, our LED red. So as long as we hold it, it will light up red. As soon as we let go, it will stop emitting light. So we've hooked up one of our terminals so far and one of our switches. Now we just need to repeat the process 2 more times. So let's look at our next terminal, which is blue. So if we want our second switch to light up our LED blue, then we know we need to make a connection from row 15 here up to row 7. So let's make that connection. So we can click on any terminal in row 7 and bring it down to any of our terminals or holes or pins, whatever you'd like to refer them as, down to 15. And we're going to change that to blue, just so we know that this wire will turn our LED blue. So now we need to connect our switch here to the positive power bus over here. So we can just select row 15 or row 5, I apologize, to our positive side of our power bus there. And we'll change that again to blue, just so we know that that will light up or basically be part of our circuit to make our LED blue. So now we have our red hooked up, our blue hooked up. Now we just need to hook up our green. So our last terminal here, or our last leg of our LED, is in row 16. So we know we need to make a connection from 16 all the way up to row 11, because that's where our final switch is. So we can select there. And again, we'll just need to finish off our switch by connecting row 9 here to the positive end of our terminal. So we'll change this one down here just so we don't get it confused. We'll make it purple just to make it stand out. So this is what your final circuit should look like. And if we start our simulation, we'll see that as we press each switch, our LED will light up a different color. Each one of our legs of our LED, with the exception of our cathode or negative N, allows for a different path for our current to flow through. So our current might flow through our green leg or our green terminal here, but it's each one of these pins will share our cathode or share that negative leg or that negative terminal. So our switches are really just controlling where our current can flow and how it can flow throughout our circuit. So this is just our first kind of walkthrough of using a breadboard to build different types of circuits. We'll go through how you can submit these and turn these in class, but for now, this will just help support the tutorial or kind of the read-through tutorial that we were working on in class. So this will help you if you're a little bit more of a visual learner, or if you just need a little bit more help or support. If you have any questions while you're working, feel free to send me a chat, an email, whatever you are comfortable with.